For the finding and applications part, we are looking into how the number and arrangement shielding wires in medical electronic connections affect electromagnetic interference, which is EMI. Our research found that in some cases, not having enough shielding wires or placing them incorrectly in connectors can lead to unacceptable EMI, especially places like surgery rooms. The key takeaway is that when people who are not expert in electromagnetic capability set up connections, it can cause problems. To demonstrate this, we use a lab setup based on real-world situations. We found that factors like the length of the connections wire and maintaining proper shielding are crucial in preventing interference. The number and distributions of shielding wires also play a big role. More evenly distributed shielding wires help reduce interference, emphasizing the importance of well-shielding connectors in minimizing EMI in medical electronic systems.
Okay, good day. Today we are connecting the dots between frequency spectrum analysis and the challenges of electromagnetic interference EMI in medical system. Let's revisit our key points from the frequency spectrum analysis presentation and see how they align with the real world case study on EMI issues in medical systems. We are going to discuss the electromagnetic interference caused by sources like electromagnetical surgical knife (ESK). Understanding that electrosurgery involves high frequency electrical currents aligns with our exploration of the ESK's frequency spectrum and its impact on the medical electronic systems. Frequency spectrum analysis taught us in our study. We investigated the impact of RMCD's wiring on EMI in medical systems, particularly focusing on the use of ready-made connecting devices, RMCDs. The study also explores the potential risks and issues arising from insufficient shielding in connectors and plugs, especially in sensitive medical environments such as surgery room. And the next is the detecting pulsations and bursts. We examine that the electromagnetic interference caused by sources like electromagnetic surgical knives in various operational modes. The study emphasizes the importance of analyzing the time domain and the frequency domain signals of the ESK, detecting predate pulsations and bursts, especially in modes like coagulation figure rate. And the third one is the burst characteristics. In our case study, aligns with the exploring the potential of creating higher frequency components during burst in ESK signal, which is crucial for enhancing efficiency when connecting with the medical electronic devices. And this underscores the significance of well-shielded connectors and the distribution of shielding wires to minimize the interference, and emphasizing the importance of practical guidance for reducing EMI in medical electronic system. Moving on to the conducting experiments, the case study complements this by showcasing experiments in a lab environment, analyzing the influence of parameters such as the number and the distribution of shielding wires inside RMCD connectors on EMI. And the last one is the EMI behavior and shielding. We stress the importance of shielding wires in the RMCD in our presentation. The case study aligns by highlighting that the amount of shielding wires significantly affects EMI in medical electronic system, emphasizing the need for well-shielded RMCDs in medical application. In summary, our journey through frequency spectrum analysis has a practical implications in understanding and addressing EMI issues in medical system. The insights gained from analyzing signals, detecting pulsations, conducting experiments, and considering shielding configurations contribute to creating efficient and interference-free connections with the medical electronic devices. And that's it. Thank you for your attention.
Thank you for my teammates. Now I'll talk about the length of shielding wires in RMCD, connecting to minimize interference. But before that, I would like to talk about more detail of the importance of shielding wires in RMCD connectors, which are RMCD ready-made connecting devices are crucial in linking various components in medical electronic system. It protects sensitive medical equipment from external electromagnetic interference, also known as EMI, and critical for accuracy and reliability of the equipments. The influence of shielding wire length on EMI we can see in our literature review are the longer shielding wires can uncompress more area, potentially offering a better protection against external EMI fails. However, longer wires can also lead to increased inductance, which might make the device more susceptible to certain types of EMI, like inductive coupling. We have to keep in mind that balancing the wire distribution and length can ensure optimal EMI protection in RMCD connectors, which comes to form a careful balance of wire distribution and length. Keep in mind that Evenly distributed shielding wires, when combined with the right length, work synergistically to enhance EMC.
So this is the fourth one, which is RMCDs in medical application. So it is widely used in medical settings for data and power transmission. Example is include cables and also connectors. This is essential cables and connectors transmit crucial information and power to medical equipment. The cables enable data transmission from sensors and imaging devices. Connectors establish reliable connections, ensuring seamless medical system operation. So the next slide is electromagnetic interference EMI risk. So the first we have awareness of potential EMI risk associated with RMCDs is essential for our workers. So it is crucial for medical workers to understand EMI risk uh, with RMCDs. So this is to inform workers can take precautions and also ensuring reliable equipment operation. So the second one we have RMCDs can contribute to EMI issues affecting their proper function, which is RMCDs can cause EMI issues in medical settings and also potential disruption to electronic system and critical medical processes. So the third one we have EMC behavior who could be influenced by component installer. So installers can impact EMC behavior of medical devices, and also proper shielding, cable setup and grounding by installers crucial for preventing EMI in medical settings. So the next slide is specific concern in MRI system. So number one, we have MRI machines use radio frequency, burst and strong magnetic fields for imaging. So MRI machines use the strong magnetic fields in order to produce detailed body images for the diagnosis. And the second one is wiring must carefully connected to avoid interference. So wiring inside remote monitoring and control device, which is RMCDs, in MRI application must be precisely connected to avoid interference and ensure accurate imaging. So the third one is choosing RMCDs with well-shaded wires, appropriate lengths, and proper grounding could prevent the electromagnetic interference and maintaining the reliability of MRI system.
The study also provides guidelines for practitioners who are involved in debugging and installing electronic systems, especially in mitigating electromagnetic interference associated with the use of ready-made connecting devices. The grounding component is most important in the effective operation of medical electronic systems, especially when dealing with ready-made connecting devices, because it helps to prevent undesired electrical interference that could disrupt the proper functioning of the medical equipment. However, eliminating ground loops, which are caused by electrical current in wires, pose a significant challenge. To address this, practitioners should connect all devices to a single grounding point for uniform electrical potential across components. Bonding procedure and connecting shielding surrounding cables in ready-made connecting devices to the ground. This guideline ensure that device perform properly without being affected by interference. Lastly, before installing the system, it is important to test and validate the grounding arrangement to ensure that the grounding system is effective, fulfills EMC standards, and enable the medical electronic system to function consistently in a variety of settings.